So in this last question in the time series on computer skill, we are actually going to be exploring the pizza sales. So it's very different from the previous example that besides the sales data, we also have the student population data. So the good thing for having this actual variable is that we know that if we have larger student population, that means we might potentially have more customers that might ending up to more sales, right? So therefore, there is some kind of causal relationship between the student population and the sales. So in order to know if we should consider use student population, the first thing we need to do, instead of creating a line plot, we want to create the scatter plot, because we want to see if the student population and the pizza sale actually have a strong relationship. Okay, so let's look at the data together. So first of all, what we're gonna do is we're gonna plotting these two data. So first of all, you can just select these two columns and then go into insert and then find the scatters and then click the scatters and then choose the very basic one. Okay, so of course, this is not the chart we're looking for. So if you want to presenting this result in the PowerPoint or in the final report, this is a bad plot because you didn't label the vertical axis or horizontal axis. So you need to actually label in it. And given we know which is the x variable, which is going to be a y variable, you might sometimes need to pay attention on if your x variable is in the horizontal axis, if your vertical axis is for your y variable. And so, but we don't want to spend time on that at this point because we only want to focus if x and y does have a linear relationship. The good thing for this data set is if you look closely on this scatter plot, it does show these two variables have a upward trend relationship, and it should be kind of strong. If you want to see, we can look at R square, right? So let's choose one of the dots, right click the mouse, click add trend line. And then after you do that, on the right hand side, you'll see format trend line. You can click here, display R square. So the R square is very, very close to 1. That means these two variables have a very strong linear relationship. That's great. So therefore, we are considering using the causal model to predicting the quarterly sales. So basically, we try to understand what's the relationship between the student population and the quarterly sale. So once we are able to get the data from the university, let's say they are having they had an idea about for the next few years or next year what is new student going to come to the university, we actually can kind of predicting what kind of sale going to look like for next quarter, right? So, but before we run the regression, I know a lot of students might like to make a mistake. I just like label my variable so I don't select the wrong data by accident. So my y variable is a sale and my x variable is the y variable is sale, the x variable is student population. Okay, so now what we're gonna do is we're gonna click the data, then we'll click data analysis, choose regression, and then click OK. So for the y range, I click this arrow. I want to make sure I select my y, including the labels. And for the x, I will make sure I select my x variables, which is here. And then I also check the labels because in my data selection, I did include the labels. And now we're changing the new output to causal model, okay. And then I will click OK. So as you can see, I got these new outcomes. Let me set up the format my cell to keep numbers to 2 decimal places and click OK. And then I'm gonna show you the result. And then I'm zooming a little bit. Okay, so as you can see, my p-value here for my slope is very statistically significant at the 1% level. So the student population does have a very strong impact on the pizza sales. And also if you look at our R square is 90%. So basically the model fitting the data really very well, okay? So now let's write down my equation first. So y hat equal to 60 plus 5 times student population. So what does that mean? That means if the student population increased by 1,000, right? We are expecting to increase our quarterly pizza sale by $5,000. That's pretty cool. So besides that, we actually can use this equation to do the forecasting. Let's see, the university tell us, okay, so for, not university, so the regions, the college student population will increase in the, so this is about restaurant, right? So we want to open a new restaurant. So in the new restaurant, we are located at the place where we have 30,000 students. So 30,000 students. So we can use that to do the forecasting, right? So let's say we have 30,000 students. How do we know the forecast the sales? So that will equal to 60 plus 5 times 30. So our sale is expecting to have $210,000 for this new location where we have about 30,000 students. Okay, so this is a different way to do the forecasting because we actually have another actual variable that already exists, and we believe that variable has some kind of causal relationship with the time series we try to predict. So then we can use this model to do it. So of course, ultimately, if you have actual variable, but also the time series data itself showing you the linear trend, seasonality, so feel free to add in the seasonality dummy variable to your data, the time index variable to your data, and also this X variable into your data to creating another forecasting model. So eventually, which model is the best? Like I said, based on the accuracy metrics we learned, MAPE, MSE, or MAE. And also, it's very important to know that when you're doing any of the analysis, and you want to separate your data between a testing set and training set, right? Testing and a training set. You're training part of the data to getting this regression output, and then you use this model to predicting the data that is from the testing set. So then you can compare the predicted value with the actual data from your testing set to see what is the value for your MAPE, MAE, and MSE, and then to determine which model is the best.